Okay, so today we're going to talk about sfm10. So SFM stands for Structure from Motion. And the goal of SFM10 is to build a sparse 3D scene reconstruction given a set of images and a focal length. Here I'm saying for each frame, but I changed that quite a long time ago, so now you only need one focal length, so it's kind of assuming that it's taken with the same camera. What can I say? Yes, also, that's the important part. It also computes the camera poses, so the rotation and translation for each view. Which means that it can figure out from where the picture was taken if you're considering the 3D scene that's being reconstructed. So that's pretty neat. And the whole point of SFM10 is to prepare, it's basically to create an input for MVS10, which I will describe later, which is software to build not a sparse 3D scene, but a dense 3D scene. Okay, so SFM10 is really a pre-processing step for MVS10, which is the dense scene reconstruction software. But today we are talking only about SFM10 because it's not complicated, but it's pretty involved, I should say. Okay, so it's basically photogrammetry. So if you know like things like call map and stuff like that, I mean it has been very popular the last few years, and I wrote this just to check it out and see if it was difficult or not. It's not that difficult actually. It's a good exercise. Here I'm describing the pipeline. I can briefly go over this. So for each view, you extract the features using SIFT. Then for each camera pair, you compute the matches, but you get rid of the bad matches using this A contrario ransack, aka AC ransack. Then you have to initialize the 3D scene with an adequate initial pair. So what's an adequate initial pair? It's one that's not related by a homography. That is, you cannot derive one view from the other. So the baseline should be large enough while having a like minimum number of matches, I should say. I'm sorry about this. Okay. So then you remove the spurious, the low confidence 3D points, and for that, I will explain that in more detail later. But you use the separation angle. Okay, so if the separation angle is low, it's very likely that the 3D point is bad or unreliable. Yeah, and I think I use something else also. I use the separation angle, and I also use the reprojection error. Okay, here perform bundle adjustment. So this is just to adjust. Yeah, so you minimize like an energy function using what's called LBFGS. Yeah. Okay, so that was for that initial pair, and then what you do is that for each remaining camera, you compute the camera pose using something called EPNP, and you add measurements to the existing 3D points, resectioning. You add the 3D points seen by the camera, you remove the spurious low confidence 3D points, and you perform bundle adjustment. It's a lot of steps, but it's actually pretty easy to implement. Okay, so here I got some examples, pretty annoying, but okay, so the manual for sfm10, it's in that archive, which you can find and then download in the 3D software page. So that's very easy to find. It's the tab up there. So here are some examples. So okay, so I know this is annoying. This is like you have only three views here, and you can figure out the camera poses. Plus, you get a sparse 3D reconstruction, which you see here. Okay, another example. So this is I think 8 frames. Okay, then you get the sparse 3D reconstruction video, blah blah blah. So let's have a look at this manual. Okay, the manual. Okay, so you can find it here without downloading anything by just looking at the archive on Dropbox. But since you have this thing that's annoying, I downloaded it and I put it into the PDF. So this is the manual. And this explained quite a bit. I mean, here I'm repeating what I said. Okay. And, oh yes, I forgot to say that the whole point of that video is because the source code is now in GitHub under sfm10. So here it is. So you can just, compile all this stuff. And this here is an example. So here you have tons of files, but when you start up, you don't have all those files, obviously. So here are the files that you have at the beginning. So those are the views. So here I have 5 views. I'm actually only using 3 of them. And the only other file you need is the sfm10 _ input, this one. So this is the input file. So here, the only input that you need is the views. So here I'm using only the 3 views. And everything else is created by sfm10. And the output is this guy, NVM file, which is used by software called Visual SFM. So it contains the camera poses and the sparse 3D scene, the points. Here is a PLY, so that's a point cloud. Okay, so you have this one. So you need like software called Visual SFM to look at it. This you can use like MeshLab or Cloud Compare to open it, or whatever software that can deal with the PLY file. So okay, and this is just to, if you want to create like a wiggle, so the _00 up to 11. What you can do is that you go into GIMP, load them up, and create an animated GIF out of it. So that's what I did here. Okay, I created this thing here from those 12 images. Okay, so let's go back. Let's go back to here. Okay, so this explains the input file. So number of images, so image file name, 1 line per image, and the focal length. Focal length. If you don't know the focal length, usually you take something like the width of the image. It doesn't have to be precise in any way. You have to input the initial camera pair. So those are numbered from 0, 1, 2, 3. So initial camera pair, if you take the first one and the third one, it's going to be 0, 2. Number of trials, don't worry about that. Max number of iteration, just take whatever is already in the file. Mean separation angle and max reprojection. Yeah, you can just use whatever is in the file. Same thing here. This is for the animated GIF frame, so it doesn't matter that much. But it's all explained in there. Let me just explain that separation angle. There's a picture there. Okay. Yeah, so the mean separation angle, low confidence 3D points, is used when checking for low confidence 3D points in the current reconstruction. Yeah, so if a 3D point has a max separation angle that is lower than the mean separation angle, it is removed from the reconstruction because deemed not accurate. Yeah, so those are this is one view, and that's, let's say, another view, another image. That's your 3D scene, and that's one 3D point. So this, when you fire the ray from the 3D point to the camera center corresponding to this image, and another ray from the 3D point to the other camera center, you get an angle, and that angle is called the separation angle. So you don't want low separation angle because it means that it's probably not accurate. The 3D point location is probably not accurate. So that's the separation angle. You do not want low separation angles. And then there's a max reprojection. Yeah, so that's another check you can do. Okay, I'm going to explain quickly what it means. So the reprojection error is just by looking at one camera. So here you have the image associated with that camera, the view. This is your 3D point. When you can project back the 3D point onto the image plane, that gets you this. But that 3D point also has coordinates on that image plane. Okay, because the 3D point could have come from this one and another view here, another view there, so it may not match when you fire the ray from the 3D point to the camera center. This UV values or XY values may not match the coordinates, the UV coordinates of the 3D point that are currently stored for that image. So that's the reprojection error. Again, you don't want that number to be high. So that's another way to check for the accuracy of the 3D point. Okay. So here, yeah, I'm explaining more things. If you change things. Okay, so this is Visual SFM. And I'm going to go into that to show you. And here I'm explaining how to create an animated GIF. So yeah. And this is basically the, okay, so here I'm running the executable on Windows. And this is what you get at the end. And you get the average depth, minimum depth, max depth. What you don't want is a max depth that's very large. If it's very large, you should really look into increasing your minimum separation angle, because it means you have 3 points that are way out there, and you don't want that. Okay, so I'm going to stop here with the manual. Now I'm going to try to load the NVM file, which is the output of sfm10, into Visual SFM. Okay, so I just fired up Visual SFM. Or maybe let's see if I can. Okay. So what you want to do is go into SFM load NView match. And here I basically downloaded the repo from GitHub, and hold on. No, let's see. This is the repo. Okay, test here. So here it is. So that's the file, nvm. Okay, let me see if I can move this sucker. Yeah. So this is what you see. Okay, so here let's look. So you have 1, 2, 3 images, and he's telling you that it has under like a little bit under 3000 3D points here for this sparse reconstruction. So, and here let me you use your mouse wheel to zoom. So here I'm going to zoom on the cameras. Let's do the scene first. So this is to pan the left mouse button, and the right mouse button is going to rotate. So here you can see, you can see the 3D scene. Okay, and this blurb here are the cameras. So let me see if I can. Okay, I think this is good enough. And here you can see, so you have one image, another image, and the third image. So here when I took the picture, I just basically panned. Okay, so I just, and that's your, so that's your camera center. That's where I was when I took the picture, that picture. That's where I was when I took that picture. Okay, so I think I'm gonna stop here. So as I said before, this is the first step in getting a dense 3D reconstruction. So this is the output of sfm10 is going to be the input of MVS10, and MVS10 is going to give us a dense reconstruction with tons and tons of 3D points. Okay, so let me go back to the beginning. Okay, so I'm going to stop here. So if you like this kind of content, please like, comment, subscribe, and I will make more. Bye.